Watch it, turn it, leave it, stop, format it, touch it, bring it, space. Watch it, turn it, leave it, stop, format it, touch it, bring it, space. Watch it, turn it, leave it, stop, format it.
All right, welcome back to part two, guys. Let's jump right into this. Learning targets, how to write linear functions from real world situations. Okay, so welcome back. Part two, we were just trying to get an idea of what does a 100 by 100 burger actually look like. And so here's what I did. I did a 10 by 10 activity, and I asked myself, does that represent this? And the answer is no. So when we talk about a 100 by 100 burger, the fundamental things that we want to keep in context is this. 100 by 100 burgers doesn't mean that we have 100 buns or 100 pieces of meat, 100 pieces of cheese, and 100 lettuces and tomato. No. What it means is that we have one bun, one lettuce, one tomato, and 100 patties of meat and 100 pieces of cheese. That's the fundamental thing we have to know in order to do this problem correctly. Let's continue. So, a 50 by 50, again, what do we need? We need one bun, one piece of lettuce, one piece of tomato. We need 50 patties of meat and 50 pieces of cheese. That's what we need. Okay. Now, based on what I just said, what would a 3 by 3 burger look like to you? Would it look closer to these guys here or this guy here? Well, hopefully you get the idea. We just needed to add one more patty, one more piece of cheese. Our 3 by 3 is going to look a lot like this. Okay. So I can write a linear function from a real world situation. We talked about what does a 100 by 100 look like. And there's some pieces of information that I'm hoping that you guys will appreciate. So at the end of the day, guys, here's what we're looking at. This is the 100 by 100. Wow, that's a lot of beef. That is a lot of beef. So now that you have an idea of what it looks like, my friends, how much is this doggone thing gonna cost? What's involved? 100 pieces of cheese, 100 patties of meat, one bun, a lettuce, and one piece of tomato. Man, what is this gonna cost? Well, what information do we need? Well, we'll bring this out individually. First thing that we probably need to acknowledge is not all of this information is all that helpful for us based on what we want. So let's talk about what is not super helpful. We don't care about shakes. We don't care about fries. Really, we don't care about the hamburgers because we're dealing with something that has pieces of cheese. So we are going to be super interested in these two numbers right here. Okay, we're going to be interested in this 345 and this 235. All right. But it takes a little bit of thinking to kind of organize our thoughts here. So let's try to organize this. Based on what I know a cheeseburger, we just saw right here, is $2.35. And what's comprised of a cheeseburger? All right, a piece of cheese, patty of meat, a bun, a lettuce, a tomato. We also saw for $3.45, we had a double by double. Now, what is that comprised of? 2 cheeses, 2 patties of meat, a bun, a lettuce, a tomato. Well, interesting thing is, if I take the components of the the 2 by 2 and subtract it by the components of the cheeseburger, what I will find is the cost of one cheese and 1 meat patty is just $1.10. Take $3.45, subtract it from $2.35. I found out that's $1.10. Now that's helpful because again we're looking for a pattern. 2 by 2, 3 by 3, 4 by 4. What's our pattern? Next thing that we might want to get a handle on is this. I know that if I know what 1 patty of meat and 1 cheese is, I can work backwards and find out what the cost of 1 bun, 1 lettuce, and 1 tomato by simply taking this 110 and subtracting it by the 235. So take the cheeseburger and factor out the pieces of cheese and the patty of meat, and what I'm left with is the bun, the lettuce, and tomato cost me $1.25. So what does that mean? That means before I even get started with adding the meat, at stage 0, I'm being charged $1.25 just to get started with that bun, lettuce, tomato with no meat. All right. My next slide. This is going a little longer than I thought because I guess I didn't know how long to expect. We got to organize this information in a table. Got to organize it in a table. Okay. How can we organize this? Well, I'm telling you what we know is this. We know that $3.45, $1.10, $1.25, and $2.35 have to be put on some sort of table. So let me help you with what that table could look like. Okay. So I'm suggesting to you, if I was to make a table, I would start at ground 0. No meat, no cheese. That's going to cost me $1.25. I know if I add 1 patty of meat and 1 patty of cheese, I'm adding 110. That's going to cost me $2.35. I take it another step. If I add an additional patty of meat, now I'm going from a 1 by 1 to a 2 by 2. That's an additional $1.10. So that's $3.45. And if I add an additional patty of meat, that's a 3 by 3. Again, I'm adding $1.10. That's $4.55. Something magical has just occurred. What just occurred to me is that we've seen problems like this before. And every time we've seen a problem like this, boop, we put in our trusty calculator. So we can actually use this graphing calculator and this information in this table to help us with this problem. So quite simply, what I would challenge you to remember is this. Because we've done this a gazillion times, all I'm doing is I'm going to that stat button, I'm going to edit, and I'm taking these values and I'm just throwing them in my calculator. Love it. I love it. I love it. We've done this. Then I'm going to stat calc, and I'm putting number 4 in there for my linear regression, and I'm going to let my calculator take a look at what pattern comes out. And this is the pattern, guys. The pattern is this. I'm going to generate an equation that looks like this. My rate of change is $1.10. My y-intercept is $1.25. And we seen where these numbers came from. You guys saw this. All right. If I put my start table, I've showed you guys how to do this, right? My start table, very simple. Instead of hitting Windows, I'm going to hit second window. And I can start my table anywhere I choose. For this problem, I want to know what 100 by 100 is going to cost me, so I'm just going to throw 100 in here. And it tells me that at 100 meats and cheese, that's going to be $110.25. Man, now does our calculator, is that number validated by what's in the real world? Well, I thought I had something to compare it against, and maybe I misplaced it. Maybe I misplaced it. Well, because my video is getting a little longer than I want it to be, let's just suffice to say, oh, maybe this is it right here. Boom. This is what I wanted to show you guys. Yeah, $1.25 it was, and this was my my equation. So the answer to my question is 100 by 100 is $111.25, and my equation for an infinite number would be y equals 1.1 or $1.10x plus $1.25. All right. We're summarizing now, guys. The summary is I can find the cost of a 100 by 100 burger and a linear function by simply trusting that the things I've learned as it relates to my graphing calculator and how to set up a table can help me in the real world. All right, this was actually a fun activity to do with you guys, and I trust you guys will do as I always say. Put that 30 minutes of studying in a day to keep your bad grades away.